So hello everyone, welcome to Screenwalks. I am Marco De Mutis, digital curator at Photomuseum Winterthur in Switzerland. And together with John Uriarte at the Photographers Gallery in London, we have created this collaborative program of fortnightly live-streamed events. Through Screenwalks, we are interested in investigating the changing role of the photographic image in its networked and digital forms. Each event is led by an artist, a researcher, or a curator who accompanies the audience to the spaces where their core practice takes place. Screenwalks can be a live performance, a peek behind the scene of an artwork, or a guided tour online, among other possible formats. We have now hosted more than 70 Screenwalk events. You can find video recordings of each one of them on our website and on our YouTube channel, all publicly accessible for free. You can browse through the archive through a system of tags on screenwalks.com or through curated playlists on YouTube. Please remember that if you found Screenwalks useful for your professional or personal interests, you can subscribe to folders for €7 a month. You'll support the program and its artists, and also get your personalized folder on folders.screenwalks.com. There, you'll receive files and extra content from the artists and researchers of Screenwalks. Now, some housekeeping information. Your microphone should be muted to avoid noise disturbances. If it's still on, please mute it now. We are recording and we will be archiving this event. Please use the public chat to ask questions, or feel free to send a private message to John or to me, and we'll bring all of your questions and comments to a discussion with today's artist, Sam Lavigne, at the end of the event.
And hello from my side too. I'm John Uriarte, curator of Screenwalks with the Photographers Gallery in London. In our last Screenwalk of this season, we will be looking at the power imbalance in the use of one of the most widely deployed surveillance technologies, facial identification. The visual calculation of the face has a long history tightly attached to the history of photography itself. We can look at Alphonse Bertillon's mugshot or Francis Galtor's eugenics, and those are only two of the most famous, maybe pioneer examples of the many Western technologies created for political control and biological racism through capturing and calculating people's faces in order to surveil and project social biases on them. The top-down hierarchical structure and unreliable technological determinism of facial identification has been criticized on numerous occasions, but even if the limitations and harmful impact of such technologies have been widely exposed, they are far from being abandoned today. The so-called artificial intelligence and the hype marketing around it has fueled even further the capture and processing of every corner of the world and every aspect of life in the name of safety. The New York Police Department, the biggest of a country in which their police forces have become significantly militarized, increased its investment in facial recognition systems since the 9/11 attacks, expanding the technology initially deployed for anti-terrorism purposes into other safety areas. Organizations such as Amnesty International have denounced the extensive reach of the, quote, New York Police Department surveillance machine, unquote, while in Europe, artists such as Paolo Cirio have launched campaigns as #BanFacialRecognitionEU. On his capture project, Cirio made photographs of thousands of police officers from Paris to then crowdsource their identification online. After printing posters of their faces and posting them on the streets of Paris, the work attracts social support and also strong political attention, forcing the censorship of the project. Serious criticism on the asymmetric use of facial recognition systems eventually reached the EU Commission, who acknowledged the need of restriction. Even if the EU Parliament recently approved a ban on facial recognition last year, it left migrants, refugees, and asylum seekers out of it, therefore continuing to deploy these technologies in some of the most vulnerable individuals and communities in the continent and on its borders. Meanwhile, in the US, where our guest Sam Lavigne is based, facial recognition has been banned in a few cities and states, but it's very actively used in many others, such as New York City. Today, we will be able to learn how to turn around these asymmetric power machine vision systems with Lavigne, who will start introducing escapism, the downloading and processing of images for artistic and political ends. He will give a performative tutorial showing how to playfully reverse the power dynamics that lay beneath the systems of facial identification. Sam Lavigne is an artist and educator whose work deals with data, surveillance, COPS, natural language processing, and automation. He is currently an assistant professor in the Department of Design at UT Austin. Sam, we are very happy and excited to have you with us today. The screen is yours.
Thank you so much. Thank you. Thank you. I'm delighted to be here. So today, what are we going to do? We're going to explore some of the tools that like the police and maybe even like counter protesters might be using. And we're going to use those same tools to kind of take a look at the New York Police Department. So obviously I'm focusing on the NYPD because I'm like based in New York. But you could, I think, use some of the same like tools and techniques that could be applied to, any police force that you're interested in taking a closer look at, either in other parts of the US or other parts, of course, of the world. And I just want to also say, like, I appreciate that lovely introduction, and want to echo again that this work is, that this thing I'm doing today is, inspired by the work of Paolo Cirio, also Kyle McDonald, also Adam Harvey, also groups like Stop LAPD Spying Coalition, which is, as the name of the group suggests, an organization that tries to stop the LAPD from spying on people. And before I kind of get into the, tutorial, like we're gonna like build a thing today, but before I kind of get into the tutorial-y part of this, I just want to briefly introduce this idea of scrapism and talk a little bit about like, what my interest in what kind of web scraping comes from. So, first of all, like what is web scraping? What is this thing that I am obsessed with? It's just when you write a program to browse the web on your behalf, right? So, imagine that you wanted every single headline from the New York Times, right? Like you could go to the New York Times website, you could select every headline, copy, and you could paste them into a spreadsheet or a CSV file or something, or you could just like write a program that does that for you. So that's all web scraping is. It's just the automation of your own browsing of the web. And web scraping is incredibly common and foundational in Silicon Valley. So, obviously we're looking at all of these machine learning systems today. All of those machine learning systems are trained on, not all of them, many of them are trained on data that is taken, that is scraped from the open web. So it's a form of commodification, right? It's taking something that's open and encircling it, enclosing it, making it proprietary. Or even if it was proprietary, or if it wasn't before, now it is, right? But also, like, I think some things that we don't usually think of as scraping projects actually are scraping projects. So Facebook is a notable example, right? Like Facebook started as something called Face Mash, which was a project that Mark Zuckerberg made to download images of female classmates and allow people to like rank their hotness, right? So this is like really important sort of like origin story for what Facebook kind of continues to be today in a lot of ways, right? Something a bit creepy. And but also like Google is a scraping company. Like all search engines are at heart web scraping companies. And my interest in it is really motivated by this question of how we can come to terms with the fact that, everything we're doing online, everything we're doing offline, just everything we're doing is being tracked, it's being exploited, it's being mined for profit, and that all the individual, seemingly like ephemeral traces that we leave behind every day are inevitably converted into structured data. They're stored in perpetuity. That our human experiences as we have them on the internet and not on the internet, they're turned into predictive machine learning models, and they're turned into business models. So the thing I'm trying to do is try to invert this kind of prevailing model of the internet, to flip the script in some way, and to exploit the fact that power also has to leave its traces online, and that those without power can collect, they can process, they can filter and sort these traces or data, and kind of like, we're all in hell together, right? And that inversion is something that I've been calling scrapism. So it's the use of web scraping and data collection as an artistic or a cultural practice, a kind of practice of counter archiving. Yeah, and the premise is that everything we need to know about power is just hiding in plain sight online. Okay, so today what we're going to do is we're going to explore COP data, and what we're going to try to do is we're going to try to make a facial recognition system able to identify members of the New York Police Department. There's going to be three parts to this, right? We have to get the data somehow, we have to analyze the data, and then we have to create some kind of system that's interactive. Now, like a cooking show, I have sort of like pre-baked a few things because it takes like a long time to get stuff. It takes a long time to process stuff. So I'm going to walk you through it. I'm going to show the code. I'm going to talk about the code. But I'm also sometimes I'm going to cheat a little bit and be like, okay, this one was already in the oven. So that's how we're going to go today. I'm also going to start now sharing my screen. I'm going to start sharing my screen. I'm just going to share my whole desktop. Hopefully everything is okay here. This looks fine. Okay, great. My website is not that useful, so I'm going to close it. But I will just mention before I get into the other stuff that I do have some resources about web scraping already online at scrapism.lav.io. So this is something you could take a look at later if you're really interested in getting into the nitty-gritty. Okay, so question again. Step one: get the data. Where's the data? Where are we going to get the data from? And there's a few places we're going to get the data from. We're going to get some basic data about cops. How are we going to get this basic data about cops? We're going to just go to the NYPD website, right? We're going to go to the nypdonline.org. And what I want here is, cool intro. What I want here is just some like kind of basic sort of info. And so I'm clicking on the personnel tab, and we can see here, I got to clean up my screen a little bit. Sorry, 1 second. I think if we go to officer profile, yes, okay, great. So what we have here is a list, an alphabetical list of every single member of the New York Police Department that you can kind of paginate through. This is definitely some kind of iframe or something. You know, I can go through here all the A's, right? To here, you know, there's still A's, we can go to the G's, right? And so on. So I want to just I just want to get this. Like, it would be nice if they provided this as a spreadsheet for us already, but they don't. At least I couldn't find one. And so what I'm going to do is let's start the scraping. The thing that I'm going to do to kind of download stuff, and just the language I'm going to use all throughout this whole thing is going to be Python. Okay. I'm going to do it all through the terminal. I use a terminal called Kitty. I like it because it's fast. It lets you preview images, and it's got a cute cat icon, which I think is really nice. And the first thing I'm going to do is just going to make a folder for us. We're going to call it cops. It's going to be on my desktop. I'm going to go into the cops folder. There's nothing in here. I'm going to create a virtual environment. And all of the code for this, by the way, is going to be available on GitHub, like after we're done with the tutorial today. A virtual environment is just a nice little thing in Python that lets you kind of isolate your dependencies. So I can install a bunch of things here, and it won't install them like globally in my system. And the first thing I'm going to need to do is I just need something to download things from the internet. And there's a library called requests that lets us do that. And so I'm just going to grab that requests library right there. And then what we're going to do is we have to figure out, how are we going to get this stuff off of here? How are we going to get this stuff off of here? The easiest way to get stuff off of here is to actually look at see what the network traffic is between my computer and this web server. And the way that I'm going to do that is I'm going to just bring up the console. I'm going to click on the network tab. And what I'm going to do is I'm going to look and just go to some letter here, and I'm going to see what appears over here. I'll do it again. I click here, and we can see this as I'm clicking, my browser is making requests to the network, and they're appearing over here. I'm going to click on one of these, and I'm going to see that this is the URL. When I click this button over here, that the browser requested this URL. Okay, it requested this URL, and then it got this as a response. And this is a JSON file, JavaScript object notation file, containing all of the data that we see over here. It's organized in a very sort of confusing and weird way, which we'll come back to in a second, but it's kind of getting all of this data here. Now, if I want to kind of, as I'm saying, what is scraping? It's like when we do this with a computer program. So we're going to write the computer program to do this. And you can see, like, if I just go ahead and go back to the sort of headers here and like look at, or at the request rather, let's see if I can find it. A little bit hard to see what's going on here. Okay, well, I can just do it this way. So copy as URL. If I just kind of go to this URL, this crazy URL, I can see like this is the data that I get back, right? What I'm going to do though, and I could just do that, what I'm going to do though is I'm actually going to copy this as a curl script. Curl is a command line program that lets you make network requests. And what's nice about copying this as a curl script is that when the browser makes a request, it includes all of this other data alongside the network request that sort of tells the server that I'm a browser, I'm a real person, right? Like actually browsing the web and not a program. And if I copy this as curl, it really is duplicating exactly the request that my browser is making. And so this will allow me to replicate the request perfectly. And there's this nice little thing that a website I love called curlconverter.com, where I can paste in a curl command, which you can see is quite hectic. Look at this crazy command that I just copied, right? And what it gives back to me is just Python code. I mean, it could also give you back like, all sorts of other code, like C code or R code or Ruby code or whatever, right? But I like this. I like using Python, so we're going to just copy this whole thing. And you'll see that in addition to that kind of like basic URL, it's also passing along some cookies and these headers, which are telling the server that this is coming from Firefox, right? So let's go ahead and I'm going to make a little script. We'll call this 001 scrape all cops.py, and I'll just paste that in. And for now, I'm just going to print response. We'll just see print response.json. We'll see just like that this is working. Okay. So if I run this 001 scrape all cops, what we should get back is like a bunch of stuff. And here they all are. This is like a little bit like, it's a little bit psycho, but we need to get more than just the single page that we looked at. This is just getting, if you kind of like dig through this crazy thing here, you can see that what this is saying is it's getting us page number 3, right? And it's also getting us one of these letters, right? So if I go back over here and kind of take a look at this page again, it's just getting us people who start, I can kind of see it a little bit better up here. Search filter value, last name, first name. Okay, so here it is. This is getting the G's, right? This is getting just people whose last names start with the letter G. So what I'm going to need to do is 2 things. I'm going to need to paginate through all of the through all of the letters of the alphabet. I'm going to get all the letters of the alphabet, and then I'm also needing to get all the pages for all the letters in the alphabet. And I am going to do that. I'm actually just going to copy this whole thing, and I'm going to replace this because it kind of added all these crazy characters in, but we don't need those. I'll just put oh wow, it still did it. That's cool. That's interesting. We're not gonna, we can leave the crazy characters, I guess. But what I'm gonna do is just take a look at my sample code, and we're just gonna take a quick look and look for just the letter G here. G, there it is. There's that crazy G right there. And I'm gonna turn this into a variable. So I'm gonna say letter equals, let's just start with A, and then I'll just replace this G in here, which is where we were getting it from. Whoop, just replace that with letter. Okay. And then the other thing I'm going to replace is this page. We're going to replace this with a variable called page. Okay. And this way we can kind of like, we can actually do the thing, and we'll just say page equals 1. Okay. And I also need to turn this into a string because it's an integer. That's fine. String page. Okay. So something like this, right? now that they're variables, we can actually iterate through it. And what I'm going to do is I'm just going to do a funny thing, which is I'm just going to put in all the letters of the alphabet in. I'm going to say letters equals A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay. And we're going to get all the letters there. And then we're going to say something like this, 4-letter in letters. Let's get all of the letters out of here. Delete that. And we can also say something like, something like this, and this will give us all the letters. Now, I'm not going to go through the whole thing. I'm just going to paste in the rest of the code here really quickly. Boop, 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 boop. And I'll show you kind of what the final thing is. So this is kind of like an example of like how you might kind of go through, and I'll just paste it and kind of walk through the rest of it. So same thing, we're saying 4-letter in letters. I'm saying page equals 1. And then I'm saying while true, which sets up like an infinite loop. And then I'm saying try to get this page here, right? And then I'm saying get all the responses. If there's no one else in there, break out of the loop, go to the next letter, right? And I'm saving everything in a file called officialcops raw.json. Okay, officialcops raw.json. And so if we run this, we should see, and I'm not going to let it go all the way, but it'll get page 1, page 2, page 3, page 4, and it'll go on and on and on and on. And while that's kind of going, I'll just show you like how complicated and confusing this data format is. So if we go in here, there are these columns, and it's a list of columns, and each has a value. Each has a value. So and it doesn't really say what it is, but I could tell that this is probably someone's title. This might be their badge number. This might be the day they started. This might be some other number, don't know what that is. Maybe arrests. I think this is how many people they arrested. And then finally, here's their full name. Here's their full name. So what we're going to do next is take this stuff, this crazy sort of like concoction here, and just turn it into a data structure that we can actually make use of, right? So again, like when you're doing all this scraping stuff, the first thing is like you got to get the data, but a lot of times the data that you're getting is not in the right kind of format. And we can see here, it's not quite in the right format. It's not quite in the right format. So we just like want to format it in a way that's a little bit more helpful for us, And what we're going to do is, and I won't walk you through this exactly, but I'm going to make a new file. See, this is still getting the E's. Let's quit out of here and let's make a new one. We'll call it 002, and we'll call this one analyze official cops.py. And inside of analyze official cops, what I'm going to want to do is open up that JSON file and kind of go through each of the columns and reformat things a little bit. And I'll kind of paste that in just so we can see what it looks like. But I won't go through every single thing in here. Every single thing in here. We actually don't need the counter. We don't need that. Okay, let's just get rid of that. Okay, we can get rid of this. Okay, great. So what this is saying is open up our raw cops data and then get all of those column values. So we've kind of looked back over here. There are these column values, right? And then I happen to know, because I spent some time looking at this, that the name is in the 5th column, columns 5. The badge number is in the 2nd column. Their title is in column 1, and their total arrests is in column 4. So what we're going to do here is just grab all that data. We also do some work to kind of split up their name into a first name and a last name. And then we are creating a little data structure that just says their first name, their last name, their badge number, their arrest, and their title. And then we're saving it as official cops.json with an indent equals 2. Okay, great. And this is obviously taking a long time to run. So I'm just going to let it keep running. And while it's running, what I'm going to do is I'm just going to copy in this actual data that I already parsed because I already parsed it. So we might as well just use that data that we have. And so I'll just grab that in here and kind of put it in, and we can just take a quick look at it. And it's called officialcops.json. Okay, So official cops.json. I'm looking at this file, and it looks something like this. So we got these first names, we got these last names, we got how many people they arrested. And, you know, before we even do the visual stuff, let's just take a quick look at this. One thing that I love to do when I'm kind of taking a look at data is use a tool called VisiData, which just lets you kind of look through data sets on the command line. And its name is, when you use it on the command line, you type VD and then either a CSV file, a JSON file, a SQL file, kind of like lots of different data files. So if I look at official cops.json, what we can see is like a kind of like a little spreadsheet here. And so I can immediately kind of like look and see, you know, some interesting things. Like, for example, if I hit Shift F while I'm looking at here, I can see kind of a breakdown of all of the cop names by you know, popularity. So, for example, there are 1,000 cops in New York City whose first name is Michael, right? 674 cops whose name is Christopher, 609 cops named Joseph. So, you know, if you go see a group of cops in New York and you shout Michael at them, there's like, you know, like about like one in 30 are gonna turn and look your way, right? And so we could sort of already, like, let's also look and see like who what cop arrested the most people. So someone named Lydell Boyd has arrested 4,345 people. Someone named Anthony Rousseau has arrested 1,988 people. So we're already sort of like gaining some kind of information about cops in New York, right? Like, I don't know, who is Lydell Boyd? Lydell Boyd, let's take a look. Oh, there he is, Lydell Boyd. And you know, what's we can just sort of take a peek. Let's see, Lydell Boyd arrested, it doesn't say here, he made $162,000 last year, and he has these complaints against him, right? This is kind of interesting. So 50A, another website we'll be scraping momentarily, 50A contains information about each cop, and it also tells you, right, it's got a photo, which is interesting for us. It also tells you how many people have made complaints against these cops, right? So I guess it's not shocking that someone who has arrested over 4,000 people has a number of kind of criminal complaints also against him. Okay, great. So what do we have so far? We got the data of every official cop in New York City, like all of the cops. We know their badge numbers, we know their first names, we know that Michael is the most popular cop name in New York City, which is pretty interesting. Let's look at this website. Let's look at this website, 50A.org. So 50A.org, again, lists cops. It also doesn't list every cop, but it particularly lists cops that have complaints made against them. And one nice thing about 50A.org is that it lists all of the precincts in New York. These are sort of the departments of the cops, like the sort of like locations of the cop stations. And the other thing that's really handy for us is that it has photos. So this is like super useful for us. So it's going to be our first source of image data for cops. And what we're going to do now is we're going to find a way to scrape this website. And one thing that, you know, one thing that is different about this website, and I already can tell this, even though I haven't, you know, because I've looked at it before, is that when I'm kind of clicking around here, it's not loading JSON data from the server like the official cop website did. It's actually refreshing the page every time I click, right? So if I click on the 7th precinct here, it's the whole page is reloaded, right? So we're gonna have to take a slightly different approach when we scrape this page. And what we're gonna do is we're gonna look at the HTML itself. So first of all, I'm gonna show the photos, but we're gonna look at the HTML itself, and we're gonna see that this, if I inspect this element here, this is inside a table, inside of a div called officers, and that each of the things that we're interested in is inside of a TD or table data element So the first one we want is officer. It's got a class called officer. Then we've got these allegations. We might as well scrape those too, if those allegations were substantiated. A year, and then a photo, which is not always available, but is sometimes available. So here we go. So we get also like in here a nice little photo. A nice little photo. So what we're going to want to do is we're going to want to download their name. We might as well download their allegations, and then we're going to want to get the ones that have photos for sure, right? We're also going to need a way to find all of these pages. So the first step in this case is going to be to scrape this page for the links to all of these subpages. And then we're going to click on these pages with the images on, and then we'll download all of the images. Okay? And we'll download all of the images. So again, what I'm going to do here is I'm going to make a, let's go back over here. Oh, it finished. That's exciting. I'm going to make a new file, and we're going to call this one, 003 scrape, and we'll call this the bad apples. These are like the bad cops, right? Scrape the bad apples. Okay. In here, what I'm going to do is, again, I'm just going to sort of copy paste the code because we're, going to run out of time otherwise. But let's take a look at it. So the first thing that I have to do is I have to install something that lets us parse the HTML of the page that we're looking at. And the thing that I'm going to do for that is install something called Beautiful Soup 4 or BS4, a beautiful library for just like looking through HTML and parsing it. This happens in two parts. The first thing is that we run a function called getEveryone. GetEveryone calls a function called getUnits, and then let's look at what getUnits does. GetUnits goes to this page here, and it clicks on. It just gets the URLs of every single precinct. These are inside of a div whose class name is commands, and then a link whose class is command. And you can see what's going on here is that we use CSS selectors to do scraping, and so we're saying get me every single A whose class is command inside of the commands div. Then we simply return the href for each of these URLs. Okay. Then we pass this to another function called scrape page, and this is the part where we're going through here scrape page. We're getting that URL. Then we're looking for this officers table, and then we're kind of going through. We're grabbing the name, we're grabbing the middle initial, the first name, the last name, the middle initial. We're grabbing the badge number, we're grabbing the allegations, and we're grabbing finally the image, right? And then we're saving this as another file, called 50acops.json. Yes. Yes. So I think that we can kind of run this and kind of go. Like, one thing that's interesting when you're doing scraping projects also is that, like, 50acops is not like an official website of the city of New York. It's something that some volunteers have put together, right? To kind of figure out who, just to make it so that you can actually see like what complaints have been issued against different cops, right? And so, there's a lot of I don't want to use the word ethic, but there's sort of like best practices when you're doing data scraping, and those best practices involve not getting yourself banned, right? Like not getting yourself blocked. And usually the easiest way to not kind of get yourself blocked from a server is to just kind of be slow in how you're scraping. You're sort of scraping that server. And what I'm doing here is I'm just putting a nice 1 second sort of sleep in. I'm telling the computer, go to sleep for 1 second between each page that you scrape. And that way, kind of like it's just a little bit easier on the servers of the sort of servers that we're looking at, right? So it's like it won't hit the 50A server like quite as hard. Okay, so this is going to do two parts. First, it's going to download all of those kind of every like the information about everyone. And then the second part is it's going to download all the images. All the downloading the images like thing is it's quite simple. It gets the URL of the image that we kind of saved when we did the scraping, and then it saves it into an images folder. And you know, there's going to be like a lot of images. So I'm also putting a little sleep in between the downloading of each image. I'm also telling it if you've already if an image already exists in that folder, don't save it twice. The actual download code is just again using this library called requests. It's streaming the response, which lets us get bigger images. It's not really like an issue for the kind of small images we're getting here, but kind of a good thing to do in general. And if I run this again, you know, we're going to see that this is going to take. Oh, I forgot to install something. Pip install TQ. TQDM is a nice Python module that gives you a progress bar. That's all it does. We'll see if I forgot to install anything else. Okay, so you can see like it's scraping 1, 2, 3 pages out of 488 pages. This is going to take quite a long time. I'm not going to let it run. I'm just gonna put in my canned example that I already have, and then we can take a quick peek at it. So the thing that it saves these as is, what do we save it as? Bad apples? I think that's what it is. What did I tell it to save as? Oh no, I save it as 50A cops.json. So I'm just gonna go and I'm gonna quickly copy that in here. So we've got cops in here, and I've got my original over here. 1 second, Finder, boom, okay. Let me just move this over here. Let's quickly get it. 58 cops. Okay, great. Okay, and then while we're at it, so I'm just going to cancel this because it's just going to take forever and who cares? We already have it. Let's take a quick look at that file also. Let's look at, well, first of all, let's just take a quick look at it. So it saved it as a file called 58 cops. It looks like this, similar to our official cops. We've got a first name, a last name, a badge number, allegations, middle initial, substantiated. Let's see who the worst cop is in New York in terms of allegations against them. Again, I'm going to go VD 58 cops. And what we're going to see here is I can kind of go through and I can sort by the number of allegations that have been made against a certain cop. So, okay, this guy, Timothy Brovakos, it looks like he's got 168 allegations against him. Timothy Brovakos. Let's just take a look at him. Timothy Brovakos. Okay. This guy, yes. Wow. Super cool. Lots of stuff against him. Physical force, abuse of authority, physical force, abuse of authority. Okay, wow. Jesus, this guy, it's like a long. Okay, so this is already just like, you know, the power of, we haven't got to the image stuff. This is just the power of having a list and being able to sort the list, right? That's all it is. You know, it's just like you got a list and you can sort it in any way that you want to. And then sort of interesting things start to sort of appear for you. This guy too, we got a lot here. By the way, I wanted to show you this thing about how much money they're getting paid, but I'm going to run out of time. Maybe we'll do it at the very end. We can come back to the most highly paid cops in New York City also. Anyway, okay. So great. We've got all the cops. We've got all these like sort of like bad cops. We've got the good cop. We've got all the cops. And then, you know, what happened here is if I let this run, it would have downloaded all of these images also. It would have downloaded all these images. Again, because I feel like we need to, you know, I don't want to actually run this because it literally will take like a day. Well, maybe it won't take a day, but it'll take a long time. What I'm going to do is just drag in that images folder from my previous example or from my previous sort of experimentation here. We can sort of take, oh yeah, so it's about a gig of images, and let's just take a quick peek in here, right? Yeah, it's about 1,400 images, and so we can start to see, you know, some of these cool cops. right? From the 50A site. Yeah. Okay. And so what we have now is we have a data set that has the kind of names and information about the cops, and we have images from any of the cops as well, right? One thing I'm not going to do, but I've done. One thing I'm not going to show you, but I kind of did as an experiment, and in kind of preparing and thinking about this project is, there's another good source of images of people who, if you know where they work, and that of course is like LinkedIn, right? And so, like one thing that you can do is, in LinkedIn is you can search for New York, police department, right? And you can kind of go to the New York Police Department, right? And you can sort of see, the people, who work for the NYPD, and you can potentially grab their facial information from here also, right? If you're interested in like doing some serious LinkedIn scraping, I recommend using their premium platform, which I signed up for a month-long trial membership for, costs $80. And then what you can do is, again, like he already knows that I'm interested in NYPD, so it's kind of like selecting, kind of telling me to go there. Let's go to people, right? Let's go to all people, and what you can see here is that there's about 14,000 other sort of results for members of the NYPD on LinkedIn, and this is like eminently scrapable. Also, and I did write a scraper. I've gotten into a lot of trouble for like scraping LinkedIn before. So I'm like maybe not going to exactly, but it's like the same thing. It's the same thing. I go to console, right? I go down here, I hit next, I hit the second page. I see what kind of pops in here. This is going to be more complicated than before, but I can see what kind of pops in here. And then again, I can see like, here's like all the people, right? And I can just go ahead and do copy as curl. I can go to my old friend, the curl converter, and what's nice about this is what's nice and terrifying about this is you logged into LinkedIn, and when you do this, if I were to run this, right, it actually LinkedIn can't tell the difference between this script running and me as a logged in user, as myself, visiting the page. Now, if you are going to do this, I mean, it's hard because it's a little bit tricky because, like, what you'll notice is there's 14,000 results, but I can actually go to the kind of end, like they limit the pagination. So at some point, they'll say like, you can't keep going further and further pages. They won't let you, right? And so what you have to do is you have to do some funny tricks. So like hypothetically, again, if we were doing this, what I would do is, I might like kind of break this up into like, I might like search for different job titles, and then I can paginate more thoroughly to the end. Or because we know the first names of all the cops, I could say like, get me, like, let's search for the word, we know that there's a bunch of Michaels. Let's search for Michael, right? Let's search for Michael, and then we'll paginate through all the Michaels, and then let's search for like, Christopher, and we can paginate through all the. So I did actually, okay, so I did do this. I'm not going to show you how I did, but I did actually do this, and so part of this images data set is that sometimes they're a little bit from LinkedIn also. Okay, so what we have now is we have like a really good starting point. We have some images. We got a bunch of images. We've got a bunch of data. Let's like actually kind of think about how we might build like a facial recognition system. And what's interesting, I think what's really fascinating here, by the way, there's sort of, what's really fascinating is there's a lot of open source kind of like off the shelf facial recognition systems that are available. So for Python, there's two that I think like are relatively easy to use. One is called face recognition. This library, let me close this. This library is like a bit on the older side. It's using under the hood something called dlib, which both like identifies landmarks in a face and is allowing you to do facial recognition. The one that I have been playing with and using is called deepface, which is a little bit newer. And deepface is actually sort of combining lots of different facial detection and recognition models into a single little package. And it's quite easy to use. there's 3 steps really to making facial recognition. The first thing is you have to find a face in an image, right? So that's facial detection. You've got to find a face in the image. The second step is you have to convert that face into basically into a series of numbers. This is called a vector or an embedding. And you convert it into a series of numbers. It might be, depending on the facial recognition model you're using, that could be it could be a list of 128 numbers, it could be 64 numbers, it could be 512 numbers. It all sort of depends on what model you're using. And then what you have to do is, once you have like your face as a series of numbers, you can think of them coordinates in a high dimensional in high dimensions, right? Like you could think of them coordinates. If you have 512 numbers for a face, you could think of those as coordinates in like a 512 dimensional space. Then once you have those numbers, you can compare those numbers to other numbers from other faces, right? So like once the face is represented as a series of numbers, it's just a question of comparing those numbers to other sets of numbers. And then if those are close, basically, if they're close, then there's a high likelihood that face is the same face as another person, right? So 3 steps. Detection, this thing called embedding, we call creating face embeddings or making the numbers, and then comparison, right? So what we have to do actually is we have to detect all of the faces and all the images we have, right? And then we have to create embeddings for all of those faces. And then we have to create a little system that you give it some new input, some new face, and it compares the embeddings in that new face to all of the other embeddings, and then it returns some kind of result. So what deep face lets us do is it lets us use different models, both for the facial recognition and the facial detection. And by default, the deep face is using a model called VGG face, and it's using a library called OpenCV for the detection. So if we run this, let's just make a new file here. Let's make a new file. We'll say 004 basic face.py. Okay, and I'm going to have to install it. Pip install deep face. Okay, let's from deep face import deep face. Okay, and kind of the very, very basic usage of this basic deep face is, I could say result equals deep face.verify, and then I put in 2 image paths, right? Say image 1 path equals, we'll do some images of me, sam1.jpg, and we'll say image 2 path equals sam2.jpg. Okay, and then I'm just going to print the results. All right, I'm going to print the results. And I also need to put in like some nice little photos of me in here as well. So I've got 2 nice little photos of me. Let's just drag those in. Okay, cool. So we got that's just a photo of me at my studio, and that's a photo of me standing outside of Leon Trotsky's tomb in Mexico City, which is like super fun. It's a really fun place to go. Okay, so let's just run this. I'll say Python 000, what are we at? For basic face.py, and what we'll see is that in a moment, it's kind of trying to do the facial recognition. It's trying to sort of figure it out. Is it happening? Is it not happening? What's happening? It's very slow, unusually slow. Maybe I'll cancel out and run it again. Let's see what's going on. Ooh, wow, that's cool. Oh, okay, let's try again. That's cool. Wow. Oh, wow. Okay, this requires some package I don't have. Let's do pip install tfcares. Great, love it. Okay, let's see if that one works this time. Okay, great. So we get back this sort of object. It says verified true. So that means that it thinks we're the same person, and it's giving us a distance. So this distance number is the distance between the embeddings of the first face and the embeddings of the second face. It's a number between 0 and 1. The bigger the number, the least likely it is that these are the same people. And so we can also say, like, let's do let's just grab one of these images. Okay, that guy's cool. We'll grab one of these images and I'll just call it like sample. And we can see if I run this again with sample.jpg, we should see that the distance is bigger, right? So yeah, so in this case, the distance is almost 1, right? So it's really like my face, let's look at these guys again. My face is like very different from that guy's face. Okay, and so that's all it really is. That's kind of like the basics of it. The other thing to note here with using this library is that you can change the kind of underlying, you can change the underlying model and the both of the detection and of the thing that makes the embeddings. So if I switch this, like, and you can kind of get a breakdown of what all of these are. If we go up here and click on benchmarks, you can see that that there's a kind of this performance matrix, which is showing you the accuracy of the model in predicting how close two faces are for using, these are the facial recognition models at the top, and these are the facial detection models, just figuring out if a face exists in the photo and what its bounds are on the left. Now, there's also these different ways of comparing the two numbers, right? So we're talking about like, we have to compare these numbers. One way is this, it's called, this is different methodology. So Euclidean, different algorithms for comparing these different numbers. Euclidean L2 and cosine. I'm going to be using cosine as this, it's called cosine distance, as a way to figure out the distance between the numbers. And so what I wanted to do is just kind of like look at this graph and see which numbers were the highest here. And so it looks like this model called FaceNet 512 is providing kind of, generally speaking, the most accurate facial embeddings, right? And then you kind of pick from over here. The most accurate one, it looks to be retina face. However, retina face, I tested out, it's very, very, very slow. It's very, very, very slow. And I tried all of these out. I tried to play around with all these, and I determined that for my purposes, the best sort of, I guess you could say, like the best compromise between accuracy and speed is using this detection model called UNet with the FaceNet 512 recognition model. And we can kind of paste those features in. All I have to do in FaceNet is I just say model name equals FaceNet 512 and detector backend equals, and then UNet in here, and also align equals false. The alignment is just like about how it crops the image around the face. So we could try this again, and what we'll see is when I run this, DeepFace, this lovely library, will automatically, if it needs to, it'll automatically like download a new model. I think I already have the model downloaded. If you don't have the model downloaded, it'll do it for you, right? So let's do SAM2 again and just see if this is coming out as true. Verified true, distance is quite small. Okay, so it's still working. Great. Now, the other thing that we'll come back to emotion analysis later. The other thing that this lets you do is I can actually replace and I'll do it up here. I'll just show you over here. I can actually replace this verify command with a find command, and it looks like this. And then in the second parameter, I can just give it a folder to work with, and it'll compare the face in the first image path to every other face inside of the folder that I give it. Now, I'm not going to run this because it takes a really, really long time the first time you run it to create the facial embeddings for each thing. But what also happens is that it's quite slow. It's quite slow in, not quite slow. It's like, about 10 seconds on my computer just to do the recognition, right? And so I wanted something like a little bit faster. And so what I've done is, instead of using the built-in DeepFace facial recognition guy, what I've done instead is I'm looking at another system that allows you to do the comparison. Another system that allows you to do the comparison. That other system is called Voyager by Spotify. And it's similar, or it would probably be the system that Spotify is using for figuring out the similarity between songs, right? And sort of like what songs you might like if you like another song. So just the way that you can turn a face into numbers, you can turn a song into numbers also, and then you can use those numbers to determine the closeness or the proximity between two different things. So like once you turn something into data, then you use that proximity to kind of like, to kind of figure out similarity. Now, what I'm going to do is I am going to just go ahead and show you the way that I've made this model here, the sort of full model. And I'm going to paste this in here. We'll call it 000. What are we at here? 5. Make model. Wow, I sort of, yes, that's fine. .py. And what this looks like, and I have to install Voyager, pip install Voyager. Great, it's installed Voyager. What this looks like is it's just going through all of the cops in our 50A JSON file. If it can't find an image in that cop database, it just continues. Otherwise, and it makes sure that the image that exists like in the folder as well as in the JSON file, and then it just says like, okay, let's make this data structure that has the name of the cop, their badge number, their image. This is for loading the LinkedIn stuff, which we'll just skip. And then what we do here is we create this, what's called an index with this Voyager thing. And this index is just going to store all the data about all the cops, like all of their little numbers, all their little face numbers, right? And then what I say is for each person that we've been looking at, try to make a representation, an embedding representation of that cop. And this was actually back when I was using different models. So I'm going to switch this over to align equals false to the UNet. And then add that embedding into our index, and append also the sort of the cop data to a final JSON file, which I'm calling final bosses, which just has the information about the cops. A lot of times what you'll notice happens here is that when you try to make an embedding from an image, it might not find a face in there at all, and so it'll fail. And so I have to kind of go through and try each one. When I run this, what you'll see is that something like this. So if I do Python make I think I have to save this. Let's see what's going on. Oh yeah, there it is. 005 make model. What you'll see is that it'll very slowly start to make our model. And again, this is going to take about 20 minutes. And then every once in a while, it won't be able to find a face, right? So it'll give us this little error about not being able to find a face. If we actually like look at, see what this face is, we might see that they might have a mask on, they might be facing the other direction. Who knows what's going to happen? So I'm just going to close this and we'll just get out of there. And then what I'm going to do is I'll just drag in our final model. And we will take a quick look at that. So just give me 1 second to do that. Cop embeddings and final bosses. Great. So what you'll get at the end of the day is 2 files. One cop embeddings file that just has like all of that face data, and one thing, this final bosses, and I'll just rename this because we don't need the UNet. Cop embeddings and final bosses. And then let's actually make the thing that recognizes, keep DOI, great. Cop embeddings, final bosses, great. So let's do this. Let's make a 006 recognize.py. And in this recognize, it's actually pretty simple. What we're gonna do is we import JSON, where we say final bosses, read as in file, and then we say cops equals JSON.load in file, and then we say import Voyager, which is our little cool cop thing. We also need from deep face, import deep face. So we're loading up all our cop data. We're saying our cop index equals from Voyager So I've got to import this index object, import index, okay, and then copy to the index, and then what do we call that? Index dot load, and then in quotes cop embeddings. Okay, great. And then finally, we need to take some input from the system. So I'll say, let's make a thing where I give it a file on the command line to recognize, and then it just shows me who the most similar cops are. Okay, so I'll say input image equals sys.arg v1. So this is get the first command from the command line. And then what we're going to say is we'll get the results equals deepface.represent. Get us the embeddings from the input image that we're giving it. Again, let's set our detector backend to be equal to UNet. We'll say our model name equals FaceNet 512, and finally align equals false. And then the embeddings are actually inside of here. They're result 0, and then in a thing called embedding. I just know this already. And then finally, what we get is if we kind of pass this into our cop index, let's query our cop index with the embeddings. Let's get the first 3 results, and let's make it so that it really kind of searches through that index. I'll explain what this does in a second. And then I'll say for ID dist in our neighbors and our dists. Let's just for the moment, we'll just say cop equals cop's ID, and we'll say let's just print the cop name. Okay, let's see if this works. So if I write recognize, and I'll do Sam1. Let's see who I look most like. Let's just see if it works, and I'll kind of explain. Okay, great. So it thinks that I look most like someone named Paul Michalak, then John Siciliano. That's so cool, and Anthony Puntini. Great names. I love you guys. I love all of these cool cop names. Okay. So all this is doing when I write copindex.query with our embeddings, right? So the first thing we're doing is we're just turning that my face or whatever face I say on the command line as an image, turn that into these numbers, right? That's here. Then when I run copindex.query, I give it those numbers. I say k equals 3 says, give me the 3 nearest cops, the 3 nearest numbers. And this query efficiency, basically the bigger the number is here, the slower but more accurate the response will be. And then it returns 2 variables, neighbors and dists. Neighbors are the IDs of the sort of results, and distances are those numerical distances. So we could also print in this dist value too. And I could see again, if we run this, it'll show me that, like, you know, I'm a 0.4 match for Paul, and kind of also for John and Anthony. The other thing that I love to do is, like, in this Kitty terminal, I can say, let's do import sub process. Kitty, this terminal that I like, can kind of preview images. So if I do sub process.run with a little command called kitten, which is very cute, iCat, and then cop image. So what this will do is it'll just like actually show me the images also. So let's just take a quick peek what's going on here. Okay, there we go. Right. So it looks like Paul Michalak is a missing image, which is interesting because maybe I loaded the wrong image folder in. I can fix that later. But yes, so John Siciliano looks pretty cool. Anthony Puccini. Do I look like these guys? I think I kind of look like this guy. I think you can make a case. You could sort of make a case that I look a little bit like this guy, which is interesting. The other thing that you know, you can do with this data is because we've got all of these numbers, right? We can sort of compare each cop to all of the other cops, and then we can sort of cluster them by how close they are together. And I've gone ahead and done that with about these 14,000 images here. So you can sort of see, like, this is a grid of all of the cops vaguely clustered by similarity. And we can kind of go in and kind of take a quick peek at kind of like which cop looks most like the other cops, right? Is it accurate? I don't know. Sometimes you can you get these sort of beautiful little moments in here, I guess, of sort of cop similarity to each other. These sort of beautiful you know, I don't know where it is. It's lost in this sea of image. Like these guys are quite nice. You know, this is a beautiful little set here. I think these guys are really nice. Um, I mean, I love this guy. That's, there's some great section of this where it's all guys with really big beards that I liked. I'm never gonna find it again though. It's all missing. This is quite nice. We're getting a little mustache kind of thing happening, right? A little more of the kind of sort of a mustache zone over here, right? And so what this is doing, this is using a algorithm called T-SNE, which basically like takes those high dimensional images, right? Like it's like we have like 512 vectors for each face and tries to reduce those dimensions to 2 dimensions, right? So an X and a Y, and it kind of groups them together. And here we are. So I love these guys. The other thing that's really nice about this deep face library is that it allows you to analyze emotion, age, gender, emotion, and race. These are all highly problematic character qualities, right? These are highly problematic qualities. But like, let's do it, to the cops, right? And what I'll look at is again, like I'm just going to kind of copy and paste this in here. Let's do what do we got here? 07 cop feelings.py, right? 07 cop feelings. Good. And so all this does is it kind of like looks through our final bosses file, and then it runs this deep face analyze. And I'm just going to get the emotion. We're not going to get into the hegemonic nightmare of race and age and gender. We're just going to get their emotions. Already problematic enough, it's fine. So then we're going to just save these all of these emotions into cop feelings .json, and then I've got a nice little function called top emotions, and the emotions that Deepface is looking for is anger, fear, neutrality, sadness, disgust, happiness, and surprise. And this will just kind of print them all out. I'm not gonna run the code that processes this stuff here, just because it takes a really quite a while also to do all of them. But I do have this kind of pre-baked cop feelings file. So let's just grab that and just kind of drag that in here also, cop feelings, and let's see who the saddest cops in New York are, or the happiest cops. Let's just take a quick peek at that. I feel like something went wrong with my my images file. I don't really know what's going on there. We'll just run this and see what happens. Cop feelings, Python, and then we run cop feelings.py, and we'll take a look at those top emotions. Okay, great. Love it. So let's take a look here. I wonder why we're missing them. It's very odd. That we're missing them. Let me just try. Is it because? One second here. I'm just trying to figure out where did all my cop images go? You know what I'm saying? We lost some cop images. Let me just drag some more images into here and see if I can kind of sort this out a little bit better. Just give me 1 second here. Maybe I'll just go ahead and do it this way. It's a bit batshit, but it's okay. It's a bit okay. Let's just do this. Just grab all these guys, and then let's go over to here, and let's go to images, and we're just gonna do a quick little thing here. Can we do that? Is that gonna work? Let's see what's going on here. All right, well, well, maybe I can fix this later. So let's just sort of, oh, you know what? I can probably just do it from the other folder. Let's just try that. Hold on a second. Let's see if we can do it this way. Cop feeling. Oh, 9. Let's see if this works better. Okay, there we go. Okay, I think this is a little bit better. Oh no, still a little bit funky. Okay, whatever. We're not going to worry about it too much. Let's look at the angriest cops. Okay, so according to the system, these are the angriest cops. Does this guy look angry? Maybe a little bit. That guy kind of looks pissed out. She does look angry. He looks more like skeptical. Maybe anger, maybe a little bit anger. I don't really see it. She definitely does not look angry. Oh no, we're in fear. Okay, so let's think about it. Are these cops really afraid? This is allegedly the scaredest cop in New York. I just don't see it. I think that this one does look a little scared to me. He looks a little scared. I can see a little fear there. We're on neutral. That guy's fairly neutral. Let's see which one are these? Oh, the sad cops. So I think these are supposed to be the saddest cops in here. I think that, like, there's a kind of, is this, I mean, do you guys think this is like a sad cop? I don't know, maybe there's a kind of sadness like behind the eyes, or there's a kind of sadness, that only like the machine can detect. A human mind can't perceive the sadness. I mean, this one does look a little, oh, disgust. Okay, so these are the most disgusted cops. I see, yes, disgust. I think so. A little bit of disgust. No, I don't see the disgust there. And here we go. Here he is. This is the happiest cop in New York City. There he goes. That guy's super happy. That guy's super happy. That guy's super. Okay, great. So now we know we kind of got the full cop emotional reality. The other thing, of course, you can do with all this stuff is, you can put it on the web, right? And so if you want to see what cop look like, you can go to the NYPD. It's a very bare bones website at the moment, but it's copdetect.lav.io, and it's just using the exact same code I use for that recognize thing, but it's just as a website, and we can like pop some cops in here. I mean, like Joe Biden, for example. So we could see, it might crash if we all do it at the same time. I have no idea. We could see, what's the sort of cop that Joe Biden looks the most like. And maybe it's gonna just crash and burn because we're all doing it at the same time. I could do it on my local copy though. Let's do it on my local copy. Cop detect web. Yeah, let's just do it here. Let's just do it here. Okay, great. Is that gonna work? Okay, beautiful. Beautiful. Yeah, I haven't really tested that thing out with like a lot of people using it, so we could be kind of like in a bad zone. Let's do the Biden one again here. Okay. Is this gonna, okay. Oh, but it's not gonna work because I don't have the images file set up. Guys, I fucked up. Well, you'll see. Maybe this will work. Maybe it won't for you. Give it a shot. See what happens. Take a look. And if it works, it works. If it doesn't work, I'll have to fix it. I'll have to fix it later. But I think that's kind of the end of my visual cop demonstration today. I'm happy to take any questions. I'm going to stop sharing.
Wow, what a ride. Thank you so much, Sam. This has been like the craziest tutorial we've had so far for sure. Very intense, but super detailed. And I'm sure like John and I already have a lot of questions. And I also wanted to mention like some of the comments I really enjoyed about like the motion recognition. Sam Hafferty said, "It's in the eyes." That's
Yeah. Yes, it's in their eyes.
Okay, so while we invite everybody to drop their questions in the chat in Zoom and or on Twitch, maybe we can start have a bit of a discussion about this project, because yeah, I think that we've gone very technical, and at the same time, like the idea of using COPS or COP data, right? Like there's like this ethical implication that I think it's a very important critique, of course, to surveillance and policing systems that John also addressed in the intro, and you also mentioned other artists. And I feel that in recent years, this critique has been kind of bounced also with a lot of like, ways in which like people humanize the single person in the force, and they have become targeted by the system, rather than seeing the kind of awareness that you bring with this project, right? Like you kind of show how the system that is put in place from the police force itself can be targeted the other way around. They can turn the other way around. So, how do you respond to this critique, or like have you also noticed this kind of like how is this project received in the US or by different audiences, and what are like the ethical implications that you see by developing this system?
Yeah, I mean, no one has seen this before. You're the first people who have seen it. So whatever response I'm having this will be the first one. So I mean, I think that like there's a sort of there's a sort of element of there's a few I guess a few things I want to say. One is like I think it's really important to sort of like, for me, like a part of a project, like working on a project like this is like it's didactic. But like for me, like I want to or pedagogical, like I want to like learn how these systems work. I want to like see like how difficult, like how easy are they to deploy, like how well, like how well how efficient are they, how like what's the computation time, like if you wanted to build this seriously, like could you actually do it using open source software? What would that mean, right? Like, so for me it's like really important as a way to like explore just like what these systems are, to actually play around with like to play around with them, and to kind of touch the edges of them, right? I think that so that's kind of like one just like sort of like level. It's like a level of like understanding the sort of technical elements, and then I think the other is like a level of understanding the sort of implications, right? One thing that like I didn't show you in that huge grid of COPS is that it's highly gendered and it's highly racialized also, right? And that's because like gender, like sort of racialization and gender is like really, 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 built into those systems, and they're incredibly problematic in that sense. You'll also, so I think that like the sort of there's a kind of like understanding that you have of the implications of these systems when you start to play around with them yourself also, and when they're available to you in a way where where maybe they're not otherwise. I mean, the other thing that I mean, I didn't get to show, but there's like there are like facial search engines now that you can use. That you have to pay for them, and they're quite expensive. But they're available to anyone, not just law enforcement, right? So you can like paste in someone's face, and then you can find other social media instances of that same person or similar people, similar looking people. So there's sort of like the tools are becoming widely available in that sense also, and I think it's just important that we kind of get a handle on what they are. I also think it's really like like if you are interested in sort of like getting these systems removed from use, right? I do think that there's a kind of it might be upsetting, for people who are policed to see themselves like in a system like this, right? And I think it is a kind of way to be like, yeah, maybe like to kind of to understand that like how problematic these systems are. Like if you are involved in law enforcement, perhaps seeing yourself in one of these systems is an opportunity for you to reflect on if you really want to be using these types of tools at all.
Mm-hmm. Thank you from my side too. I was also thinking, and like we were like Marco and myself, we were chatting while you were giving the tutorial, also about the and given that both our institutions are photography institutions, about the role that the image has in all this process and all these systems, how like these models are actually comparing photos instead of like the bodies directly, and also how problematic it is to try to calculate a face and create like transform a face or like a photo of a face into a number and work out of that. I mean, it reaches certain like absurdity as we've seen on the clusters, but there are also some other serious considerations no on that process. And yeah, I was just thinking, like, if you could or expand a little bit on that, or like give us any examples of things that you have found that you think are like good examples to understand the problems that this way of calculating an image brings into these systems.
Yes, you mean like the sort of the problems of, the sort of conversion between pixel data and the sort of facial embedding vectors or whatever.
Yeah.
Yeah, I mean, there's a few things. Like one thing that I didn't really talk about is that like a lot of these systems are trained on a data set called labeled faces in the wild, which is a cool, funny name for something. But it's a lot of I think like there's a few approaches to sort of like first of all, like there's the issue of the training data. Like, where did the training data come from? Was that consensual? Is that not consensual? Like, what does it mean if your face was being used to train a system that's like deployed by law enforcement, right? Like just a kind of like that on like a single level. And then, of course, the other thing is that like there's a kind of normativity that naturally systems kind of enforce about like what a face is and what a face isn't. For if I didn't have a nose, for example, for some reason, like would that be part of like the system? Would it not be? Like how does it sort of interpret like the really wide variety of like human faces? And then of course like the issue being also related to, again, like specifically like race, where like historically these systems have been unable or far less accurate at kind of analyzing images of not white people, right? Which is in some ways also a really, potentially like a good thing, right? Because it's sort of like the racism baked into the sort of people who are making the systems actually maybe ends up having a positive effect, because then the system is unable to kind of track people. But the flip side, of course, is that folks who aren't white frequently get misidentified, right? So the numbers, it's the similarities, right? Because of inaccurate embeddings, like lead police to arrest people who like aren't even the people they're looking for, right? So this kind of misidentification is kind of built in. I don't know. I mean, it's also there's something I think also just kind of quite interesting in general about like what a lot of what I feel like what's going on right now with computation and like machine learning is just like finding new things to turn into numbers, basically, right? So like the face is an obvious, one that people have been working on for a long time, but it's like finding new and better ways or more advanced ways of turning like language into numbers and turning like action into numbers. So it's like that process of the creation of the vector, the creation of the embedding is a kind of process of like, I mean, colonization might be a little bit too strong of a, in a sense, maybe too strong of a word, but there's a kind of like it takes something that is not in the domain of computation and then puts it inside the domain of computation, right? So I think the thing that we should be thinking about also is like, as we go forward, is like, what are the things that are not within the domain of computation, that computation, or those that are sort of like the power brokers of computation are going to try to bring into that domain of computation through the process of creating embeddings, right? Like that's really what it is. It's just turning some input into a series of numbers, right? A series of floating point numbers. And that I think, go ahead.
No, I was just going to say that it's like the statistical computation of the face. No, I mean, it has this really deep relationship with photography from the very beginning of photography, but nowadays it has gone, I would say, into emotions, like through AI companions and all this kind of apps and models that are being created that are trying to calculate the emotions to somehow also monetize them. No? I mean, we've been talking mostly about surveillance and control today, but there's all this other area also of monetizing all these systems. There's a long message,
Wait.
a message on the
Wait,
chat that
I
I
have
want
to
to
show
read.
you. It finally worked. Just 1 second. Okay. Okay, cool. So this is the New York City cop that Joe Biden looks most like. I think it's actually really like I think it's actually like a really good, like, I don't know, it kind of looks like him, you know what I mean? Like it
Once
kind of
you
looks
see
like him.
it, you see it.
We'll do Clinton. Yeah. I feel like the Clinton one isn't as good. Like I did this yesterday. I just don't think that's like as good of a match, like just to me is not as like strong of a resemblance. But yes, good, it is working. I wanted to do this one, but it but it can't find, it had trouble finding the face, right? So this is like an issue, I think, with using this in the real world. Like there's two issues. Like one is that, we only have 14,000 images. We don't have the full sort of data set. But two, sometimes like, if it can't kind of get right, if it can't kind of find the face, then it sort of fails. Anyway, I'll stop sharing.
I
Please, what's
wanted
the
to
next
bring
one?
maybe
Yeah.
a comment from the chat from Michael Simon. It says, in 2018 in New York City, we fought for and won the Right to Know Act in order to get cops to give their info for every interaction, because so many were walking away without ability for recourse. But it's been a total failure of implementation. I see this as a very practical way for us to snap a pic and make them searchable to get recourse after an interaction. And I think, I'm curious, of course, to hear what you think about it, especially because like you live in New York City, so you also can relate to this reality very much. But I was also thinking that in 2019 and also 2020, like in this moment, we've seen the riots and protests in Hong Kong and then in Chile, and these ideas of the face, also this kind of, I think there was also an app trying to get cop face data in Hong Kong, and then later Paulo Cheers, which was mentioned at the beginning in Paris. There seems to me there's really like this weaponization of the face that has been going behind these two sides of these protests. I don't know if you can talk a little bit about that and how you see it maybe in your specific reality and how it kind of the project came about as well. Like how do you see this also related to what Michael wrote in terms of like the specific reality in New York City and this Right to Know Act?
Yeah, I mean, like I got interested in doing. I mean, I think that what Michael's saying is like right on, and it's the the typical thing is like the New York, of course, like NYPD is like not following, like they never have followed the rules, and like it's like unlikely that they ever to expect that they ever will, right? But like I think the idea actually for this one started with a friend of mine, like captured from her window the police, what she believed was police abuse of somebody, and she couldn't like see their badge number, and so she grabbed a photo of their just of their face, and was like, how but there's what do you do with that, right? And so that's kind of the sort of beginnings of why I got interested in this, is to think about like, well, there are these moments where you need to identify someone doing something abusive, and you're not really able to do so, right? So I was, that's kind of how I was really thinking about it as a tool for people who are kind of monitoring what the police are doing and trying to intervene. I mean, the other thing is, I live right next to a cop station, and just they always park on the sidewalk. It's so annoying, It's illegal. They're not supposed to do that, but they don't ticket themselves, right?
I guess that's also
really
like
annoying.
one of the things
It's really annoying.
like as I mentioned, this critique that sometimes come from like specific media about humanizing cops or things. it doesn't consider the asymmetry between the kind of the power they have and the injustice that many times like victims kind of suffer from this system. So I think this has to be taken in consideration when we talk about like the way in which we can use this data and we can kind of turn this system around it. And there's like a sentence that you said that I wrote down, which I thought was quite interesting, or like it made me think. You said like, this is the power of having the list and sorting the list, which is like very simple, but it's also connected to what you mentioned about this quantification, like this idea of listing or quantify something comes with a power, comes with a certain like power that can be used by different actors and from different purposes.
I mean, I think for me, it's really, I mean, let me come back to that for just a second, but I just want to mention one other thing actually before I forget, which is that there was, something I saw on Twitter. Yes, I love that Mastodon account, Sam. Like something I saw on Twitter, which was like really disturbing, which is, there are all these, kind of incredible student protesters in New York at the moment. But they're being like heavily surveilled, and there was something going around about people asking, offering money for photos of protesters' faces, right? And I think that like what we're seeing is like there is it is the power of sort of like doxing and trying to sort of like ID people and through IDing them like undermine them, and to me it's really important to, again, just to sort of like have access to these tools and understand the implications of them, and not be on the not be on the side of the abuser, but on the side of those who are like seeking to struggle against seeking to struggle for a more liberatory world, a more liberated world. But like for the as far as the sorting of the lists go, I do think about this quite a lot, and that's specifically like in relation to like web scraping and stuff, which is that like when we think about databases, when we think about websites, we're really thinking of them as these like little interfaces, but really what they are is like they're front ends to databases, right? Like almost all websites are like a front end to a database. A database is many things, but it's also a list. It's a list. It's lists of lists, right? And it's and in a way, like the access to like full read and write access to those databases, to those lists, is like where it's one place where power kind of comes from or resides. And web scraping lets you do this thing that's I think very important, which is it lets you kind of it lets you re-database the web. It lets you it strips away the interface and goes back to just this is actually a database. This is actually a list, and we have the ability to query the list, in any way that we want to once we have that information. There's also limitations to that approach, right? So that's like the sort of James Scott, like which he would call like the synoptic point of view, right? The bird's eye point of view. There's real limitations to that point of view also, right? But it's still interesting to have access to it. And and so I think that like for me, part of like the sort of project of like scrapism is to help people regain access to these databases or gain for the first time.
Yeah, but not only access, no, I guess it's also visibility, in the sense of like a scraping of, I mean, downloading the data and downloading the images is so important, but at the end, like the sorting or like the organizing and the pointing to something among those like huge amounts of data is where the actual power of the process is, because that's where like something gets like gets a meaning, no?
And even the facial recognition is a sorting algorithm, right? I mean, making the embeddings isn't really sorting, but then the thing that actually does the recognition, that says like, is this the same person as this person? It's really not saying, is it the same person as this person? It's saying like, let's make a list of all of the numbers and we'll sort them in the order of distance, right? And then whoever is closest, that's the same person, so even that is like a process of sorting a list.
Yeah, and I mean, it's, I mean, all sorting has like, it's applying some kind of power, but with these technologies, as we've seen, they're so inaccurate and they have so many issues within them that we are adding like these inaccurate and problematic systems into an already like power imbalanced and very asymmetric power relationship between police force and the citizens. No? And that's, I guess, like what the projects that highlight somehow and where the power relays. I think, I mean, you've been already more than 1 hour and a half.
Yeah, we've kept you here hostage.
It's my pleasure.
We're gonna let you go.
Yeah.
But
Yes, thank
you
you.
know-
I do have one other thing to say for the members of the audience. If you want to, just send me photos of cops and I'll add them to my system. Just send them to me. Send me just photos. I just need you have to send me their name or their badge number too. So, but if you can just send me a photo has the badge in it, then I'll add it to the system. So just send me your photos.
For everyone in
and
New York, right?
yeah, they gotta be in New York. Otherwise, I mean, if you want to do it in another city, you should talk to me too. But like, send me your cool photos and we'll get them in there. So yeah, that's all I gotta say. Yes, thank you so much for having me. It is a true pleasure to be with you today. And I'll also upload some of this code later on once I clean it up a little bit.
Fantastic.
Thank you so much.
Thank you so much also from me. Thank you to everyone who joined. And this was the last majestic screen walk of the season. We're gonna come back after the summer break. So we wish everybody like a good time off the screen for now and see you back in, I guess, October-ish.
Yeah, something, sometime around that. We just need to take a break after so many skin walks, but we will be back and we already are planning some really nice ones. So looking forward to meet everyone after the summer. And thank you, Sam, again. Thank you all.
Bye.